Hi everybody, my name is Tony St-Pierre. I am the president of XEOS Imaging, and I will show you today what we've developed in artificial intelligence for mapping using Lidar point clouds. First of all, who is XEOS Imaging? We are a private company based in Quebec City. We are specialized in aerial photography and Lidar surveys. We do a lot of innovation in artificial intelligence. We developed since 2018, and we have submitted some patent in Canada, US, Europe, and Australia for what we've developed. We are 30 employees, and about a third of our employees are working in research and development. XEOS Imaging has built over the years a very high capacity for both capture and processing. We have processed over the last few years petabytes of data. We have our own in-house cluster to process data and distribute parallel processing. So we are built for big jobs. Why do we use artificial intelligence, and what can it bring to us? First of all, our observation over the years is that there's a lot of data on the market, but a small portion of that data is very used by our clients. For example, with Lidar, people are extracting digital terrain model, but more than that, there's a lot of information that is not extracted. Why? Mainly because photo and Lidar are not in a format that can be queried very easily. So artificial intelligence can play a role to extract information from the big data that is hard to query. For example, we can take a Lidar point cloud and extract the building footprints, extract the tree crowns, the tree elevation, the blue spots, a lot of things that we can extract, and this can be transformed into shapefiles that is very lightweight and easy to work with. So no need anymore to work with big Lidar data if you already have the shapefiles of exactly what you want. So how does artificial intelligence work? How do we do that? There are three simple steps. The first step is to classify the raw Lidar point cloud by artificial intelligence. So we have developed in-house with our team AI model to classify the point cloud. So we can exactly tell or say this point is a building, this point is vegetation, this point is a wire. The quality of the classification is so good by artificial intelligence that we can then just isolate each layer and map automatically each of these layers. As a third step, we can do optional analysis. For example, if we have mapped all the power line wires, we can also know exactly where the vegetation is. So we can do a automatic analysis to detect where the vegetation is too close from the wires. Same thing for the blue spots. We can automatically detect or map and do the analysis to prevent or to know in advance where there will be some floodings if there's a big rain event. We have developed in the last 2 years many map layers that we extract from the Lidar. building footprints, vegetation, blue spots, water boundaries, roads. So a lot of layers that are available. Let me show you each of these layers product by product to explain a little bit how it looks like. From the Lidar classified by AI, we can easily extract the building footprints. The building footprints represent the projection of the roof on the ground, and it is delivered as a shapefile. So it's very lightweight and easy to use, compatible with all types of GIS, and we add attributes to those polygons. For example, we add the height of the building and also the minimum altitude of the flooring of the house. If we overlay the orthophoto or the true orthophoto, we can easily see that there are some buildings or sheds or garage that are under the canopy, but we can easily map them because with the LiDAR we have all the information in trees, so we can go and extract and map correctly all those buildings. Ground permeability and heat islands can be easily extracted from both photo and LiDAR. For example, we have here a shapefile extracted from the photo that shows the ground permeability. In red, we have the impervious grounds, and in green, it is permeable ground. We can look at with the orthophoto, and we understand easily both categories. If we couple that with the trees that are 3 meters and higher, then we can automatically detect where are the heat islands. So you see on this example that the red part on the red side of the example, you have a big heat island. We can map the vegetation group by height class. We take the LiDAR point cloud that is classified by artificial intelligence, and we isolate all vegetation classes. And then we can group all the 3 classes, which are the first class that is below 1.2 meters or 4 feet. We have 1.2 to 3 meters and 3 meters and above. So you see in each color the 3 classes. Another product is individual trees and edges. By artificial intelligence, we have developed a model that can segment it or separate each tree or isolated or in a tree stand, and by that we can after that isolate and map each tree individually, and we can add some features or attributes like height of the tree and area of the crown of the tree. We are actually working on a project to try to learn to the computer to recognize the tree species, but actually it's not yet commercially available, but in the next year we expect to be able to commercialize the tree species. Blue spots and surface water flow. With the digital terrain model that we extract from the LiDAR classified by AI, we can modelize and generate a map of all the depressions that will accumulate water in more than 30 centimeters in depth if there is a big rain event. A big rain event for us is when it rains enough to make that the sewage, underground sewage network will be saturated and will not make its job to eliminate the water. So the water will flow at the surface of the ground and get accumulated into those blue spots. If we overlay the building footprints, then you can see directly where the houses will be flooded. Knowing that in advance, then you can do or try to do some work to avoid having this water to be accumulated in those blue spots. We also give a layer that is the low point of the blue spots, which tell you in attribute the exact depth of the blue spot. We also provide a layer corresponding to the watershed or the micro watershed that brings the water to each blue spot. This is information that is very important if you want to make works to reroute or redirect the water from a blue spot and remove it from there. Then you have to know what area is contributing to bring water to this blue spot. Another layer that we provide is the surface flow direction of the water. So it tells you exactly where the water will flow and will pass on the ground. Another product is the water boundaries. We can provide the exact water boundary of rivers and lakes that is extracted from the Lidar only. This is something that we've developed and that we have a patent pending, and it gives you not the legal height or the legal position of the water limit, but the exact limit where it was when the Lidar aircraft passed and took the survey. The road layer is another product that we can provide. It's the exact limit of the road, or paved or unpaved. We also map the bridges and overpasses. So it's quite simple, but very useful. So all the bridges and overpass can be mapped in a shapefile. Swimming pools can easily be mapped by artificial intelligence. We can do that both by photo, based on photo, or based on Lidar. For each pool, we map the exact boundary, and we can give in attributes if it is a in-ground or above-ground pool. You can go on our website and order online mapping data. We have for the Canada all the locations where we have data available, and you simply create an account and choose the tiles, 1 square kilometer tiles that you want, and it's very easy to pass an order directly. New products that are expected for 2025. We have for the power lines, for transmission lines, we have all the towers and the wires. We have for distribution lines, we have all the poles and the wires too. We have, for example, for the ditches, We want to map in 3D all the ditches and also map all the culverts. We also want to commercialize all the fences around the pools. Roughly those are the main projects that we are working on and that we expect to be able to commercialize those products within the next year. So thank you for your attention, and I hope that you enjoyed.
Get from the LiDAR. Very impressive. And you've obviously stimulated the crowd because we have a whole series of questions in the QA. So let's get right at those.
Okay.
Will the patent be on the AI model or on the approach? And I guess you mentioned a few patents, so if there's a difference there, maybe you could elaborate on that.
The patents are on uh, the approach that we're using, because the AI model or code, we cannot patent that, but all the steps that we're using and the way the approach we have, then it is that is patent.
Very good. So following on that, perhaps, what is your AI product's accuracy? And I'll just keep going with this question about IOU, intersection over union, and overlay accuracy, since every point cloud state-of-the-art deep learning models fall far short of even 85% of overall accuracy. So I'm wondering if the question is related to things like, how well can you do a rooftop if there's a tree overhanging, just to give it a little context, perhaps. But would you like to tackle that question?
Yes, the accuracy first. The accuracy is dependent on the lidar accuracy, and the lidar, uh, the spot diameter and the lidar point density. So depending on what product we're doing, each of those parameters have an impact. But roughly, we have maps, elements that vary between 10 centimeter up to 1 meter accuracy. It's the range of accuracy we're having. Regarding the IOU is a kind of parameter that is used in artificial intelligence to qualify the quality or the success of the classification. And we are about 95, 97, 98% of quality.
Oh,
And maybe regarding the quality, each of our product is delivered with metadata that is documenting the accuracy, documenting, for example, in our quality tests, we're documenting, for example, if it's building footprints. So what percentage of buildings have been detected, what percentage of building is correctly mapped, because some of the buildings might have some defects, and what is the percentage of true positive or false positive, sorry, false positive or false negative. But roughly, we are around 90, above 95% of accuracy on each of our product.
impressive. Great. Another question. What are the ideal input data? LiDAR and imagery? What are the ideal input data requirements to achieve optimum results using your AI model? So I had a sort of similar question
Okay.
regarding, does the addition of imagery with the point cloud, really increase your capability much more? So maybe you could speak to that a little.
It depends. We have multiple AI models depending on the product we want to output. Uh, Most of the products we're outputting are based on LiDAR only.
Okay.
But we need a good LiDAR.
Mm.
And I mean a good LiDAR is a high point density with a very small spot diameter
Yep.
because the spot diameter has an impact on the horizontal accuracy.
And
We
when you
have
say high, what would you consider to be good LiDAR? Sort of 10 points per square meter kind of thing, or pulses per square meter?
uh, the ideal is 30 point per square meter.
Okay.
But for example, if we want to map the trees, we can take 15 points and higher point density and be able to map it. But it will be best if we have 30 point per square meter. We can map the buildings with 10 point per square meter, but the buildings will be better if we have 30 point per square meter.
Right.
Well,
Sharper edges, more defined.
exact. And to complete the answer for the question of the person, we have other AI models that are based on photo. For example, if we want to map the permeability of the ground, then it's better to only use photo. So we're doing a mix.
Okay. Great. Another one here. Have you used AI to classify ground returns in steep terrain and remove noise and low vegetation? And following that, on the same from the same questioner, if so, how does the process work given the ground lacks a distinct geometric shape like a building? I am curious about the methodology and expected accuracy. So I guess this is, are you able to separate that low vegetation from the actual terrain?
Yes. The answer is yes. And uh, I would say one of the parameter that makes that we are different from any other and that we have been able to go over the kind of limit that all the research group are obtaining at 80% quality. One thing that is different in our case is that we keep classifying unclassified point. It's
Mhm.
a little bit weird said like that, but if you have points that are at the ground and you have low vegetation at 20 centimeter above, most of the algorithm or the AI model are not able to distinguish or they classify everything as ground. And if you are in steep terrain, then it causes problem. But in our case, we keep only the lowest points as ground, and all points that are a little bit above then are classified as unclassified or vegetation, depending on the patterns. And roughly that's that.
Okay, very good. Um, any mention about expected accuracy in that kind of environment?
Oh, the expected accuracy is straight the LiDAR accuracy.
Okay,
So this is only classification, so we don't change the position of the points.
right. Okay, following, I think it's the same person. What is your strategy for mapping and monitoring water bodies by LiDAR, given that they change with the season and dates due to factors like precipitation, snow melt, and tides? And I think you were quite clear in your talk that it was the water boundary at the time of flight, but maybe
Exact.
you could elaborate on this question a little bit.
Oh, it's really easy. The artificial intelligence is maybe one point. We're not uh,
doing like Chat GPT or other things, system like that that are creating new things or inventing things from what they know. In our case, we are teaching the artificial intelligence to recognize specific things. So we train our AI to recognize water, and it only the only thing it makes is if there is water, it will detect it. And we developed some strategy to after that uh, detect the real edge of the water ponds or water surface.
Yes, because often you'll see perhaps a DTM where maybe someone has not done that good a job at separating ground from water, and we often will see these sort of tin artifacts. I take it you folks must have to deal with that to ensure that your boundary is as precise as possible, so you're not getting those artificial water points perhaps creeping up on the bank. Is that
Uh, it's part of the training. The training must be perfect. If you are training errors, the result will be errors. So
yeah?
everything has to be perfect straight from the training.
Very good, very good. Um, can your AI models measure the volume of underground water?
It could, but actually we did not train or we did not work with bathymetric lidar R&D program. We did not develop, but we are doing a lot of bathymetric lidar,
Mhm.
uh, but we the list of development is too long, so it was not yet our priority.
I think what they may be getting at here would be sort of groundwater table when they say underground water. And obviously the LiDAR doesn't penetrate to the ground, so I would be surprised if you can, but sometimes one can infer other information. Any comments about groundwater?
No,
Okay.
groundwater, no, no.
Yeah. Okay. And
Regarding the ditches and
yes,
the
culverts.
yeah, the culverts, this is a project that is ongoing, and even if the culverts are underground, in this case, we think we can succeed in mapping them because of the environment around each culvert. And we already have all the water flow, the surface water flow. So we think we can train the AI to recognize and distinguish where are located the culverts.
That would be quite impressive to be able to do it because there's some cities, as we know, where streams just disappear and go under that infrastructure and then reappear out the other side of that city. Uh, and I can appreciate your work you're doing there because a lot of people I don't think realize how important having the culverts in the elevation model are in order to further use it for flood modeling or routing of water, like you say. Um, so
Yeah,
very
yeah,
important work.
yeah. And our goal is to be able to product some breach DTM uh, automatically. So that would be great.
Mm. Another question here. Are all your products for individual objects, trees, roads, buildings, etc., derived from the AI point cloud classification? If so, what kind of validation is made on these results?
We're producing each layer independently, and we have a team here that is doing QA, QC, and giving some statistics on the results. So once we have good results with a model, then we can produce data with it.
Very good. Very good. I noticed somebody put something in the chat. I'm just going to have a quick look here. Um, No, okay, nothing there. I was very curious and excited to hear your comment about working on species, differentiation of trees, and your projection that perhaps that will be commercially available next year, I believe you said. That's very exciting. Of course, people in that environment who've worked with forestry, it's kind of the holy grail that
Yeah.
has been unattained. So, can you elaborate a little bit on with obviously
Yes.
you've got some secret sauce there that you don't want to.
No, the secret sauce, we submitted a patent on that. So we now can talk about the secret sauce. Uh, the goal or the way we work is we're building a two-branch AI model, one with analyzing the photo and one analyzing the structure of the tree from the LiDAR.
Okay,
And actually, we're getting very good results. So it's
excellent.
working. The good news is it's working. Now we're training to add a lot of data from different regions, different species, in order to increase the amount of species we're able to recognize. And in fact, it's not directly the species that we're actually able to tell is the genius.
Okay,
So we're able to say it's a maple, it's a birch, it's uh, no
Sti-
matter PTA or things like that.
still that's impressive. I mean, we'll cut you a break on the hey, you can't differentiate red spruce from black spruce maybe, but spruce from fir from pine, that's going to be a real breakthrough.
Yeah, yeah.
A couple more questions have popped up. Um, Typically, we use AI to automate the process of extracting the object. Therefore, we are unable to measure the volume of water automatically with AI, and post-processing is required. Um, I'm not, I guess that's just more of a
So
comment.
that's true. We're not measuring the volume, the volume of water.
Yeah. And there's a question here from Sunday asking, I'm currently in my last semester at geomatics engineering at the University of Calgary. Is there an opportunity for me to join your data collection team as entry level? So the
Yes, we're always open to hire good people. So you can go on our website and submit his resume.
and I'm just back from Quebec City, and I can attest that it's a beautiful city and uh, a great place to spend your time. Well, Tony, I don't see any other questions. Fascinating talk. Real exciting the work you and your colleagues are doing there. It's real nice to see a company put that much effort into R&D, and obviously I'm sure it's paying off for you, and sounds like it's going to pay off big time in the future, where you'll be able to offer some quite unique derived products from LiDAR and photos. So very impressive. I've learned a lot, and I look forward to meeting you in person in the near future.
Good. I'll be at Geo Week, so we
Oh,
can meet there.
very good. I'll look for you.
Thank you very much.
Thank you.